Class, let's go to knock this out. I'm going to do 8.6. Says for exercise 1 through 8, identify the function family to which G belongs. All right, so let's start there. We see here at the beginning that we've got, remember I'm only doing the odd ones, gx equals the square root of x minus 2. That tells you right there it's going to be the square root. So number 1 is square root. Number 3 says g of x equals the absolute value of x plus 9. That tells you right there it's going to be the absolute value. Number 5, g of x equals 2, and then it says x plus, to the x plus 1 power. The minute that x is over there with the exponent, we know there's going to be exponential. Number 7, g of x equals x squared plus 2. This time the base is x, not the exponent, which means this is going to be quadratic. All right, you have 2 through 8 to do. Let's keep moving on. Number 9 is a straight line. And we know if any straight line has the word line in linear, so that means it's a linear equation. Let's see, number 11, this is curved, okay? When we have this, this tells me that it's going to be cubic, okay? Cubic. And it's curved and it's going up and down, cubic, right? Let's go and move on. You have 10 and 11, or 10, 12, excuse me. Number 13, well, this is a parabola, and we know all parabolas are quadratic, so this would be a quadratic equation. Number 15, this is curved from one of the axes up, and when it's curving, that tells you it's going to have exponential growth, not linear growth, right? So this has got to be exponential. When it's curved, it's not curving the opposite way like an S, it's just curving kind of like a bend. It's exponential growth. Number 14 to 16 are yours to do. Number 17 says to tell whether the points appear to represent linear, exponential, or quadratic. So if I was to go ahead and connect these lines here, it's the easiest way for me to tell. I can see that it's going to come down to a point of a vertex and go back in the other direction. Definitely a quadratic line, quadratic. Number 9, or 19, excuse me, again, just connect these dots. Some of you probably don't even need to connect it, because you see that the growth is increasing not at a linear rate, not like a line, but exponentially. It's getting I guess the rate of change is increasing more and more. So that's going to give us an exponential growth. All right, 19, 20 are yours. This one says for 21 through 23, or actually through 26, plot the points, tell whether the points can be represented by linear, exponential, or quadratic functions. So let's use what they gave us first. Let's look at the increase on top. We see we are adding 3 here, right, from -6 to -3. Then we're adding 3 again, all right, to get to 0. Again, we're adding 3. And then once again, we're adding 3. All right, now we got to check the bottom. I'm sorry, this should just be like this. I don't know why I started that. So over here, we're subtracting 1.5. Or we're actually adding, I'm sorry, adding 1.5. And then over here, we're also adding 1.5. And then over here, we're adding another 1.5. And once again, we're adding 1.5 again. Now, because this is a constant rate of change, this tells us that this will be linear. A linear table represents a linear table. Linear. And you could also take, by plotting these, right? You take -6 and plot -1.5. You take -3 and then plot 0, right? Then 0 and 1.5, that'll be here. Then 3 and 3, and then 4, 6 and 4.5. And you can see we have a straight line going through these points. That is definitely linear. All right, let's look at we have 22 to do. I'm going to look at number 23. Over here, we're adding 1. And then over here, we're adding 1 again. And over here, we're adding another 1. And adding 1 more. And over here, well, in order to get from 1 over 16 to 1 over 4, we would have had to multiply everything by 4, right? Because if you have 1 over 16 and multiply it to 4 over 1, that's going to give you 4 over 16, and both of them can be divided by 4. And that's going to give us 1 over 4. So you can see why this was multiplied by 4. And this is also multiplied by 4 because 4 over 1, right, would make 4 times 4. Sorry, 1 times 4 would be 4. 4 times 1 would be 4, and 4 over 4 is 1. And then 4 divided by 1, well, that means we're multiplying by 4 again. And of course, 4 times 4 should be a multiplication, not adding, sorry, will give us 16. So since we're multiplying and not adding, this is going to be exponential growth, exponential. All right, let's move on. Our next side is, okay, we're on, you're doing 24 and 26, that gives me 25. Let's work this one. This time we're adding 1 to get to -2. We're also adding 1 for -2 to get to -1. We're adding 1 for -1 to get to 0, and then we're adding 1 again. So this was a constant. And over here, for 72 to get to 36, I would have to divide by 2, right? And then for 36 to get to 18, I would also have to divide by 2. 18 and 9, I would have to divide by 2. And 9 to 4.5, I would have to divide by 2. Now, a lot of people say, well, what are you doing with dividing each time? But you could also say that this is, instead of dividing by 2, you're multiplying by 1/2 and saying the same thing. So I'm going to change all these to show multiplying by 1/2. And we said that if you multiply the same thing every time, that it was exponential growth. And that works even if it's a fraction. The fraction is just a rational number, right? We're still dealing with numbers. So this is going to be exponential growth, number 25, exponential. All right, and I think that's the last of them. You have the rest. So I'll see you in class for grading, and then we'll start 8.7. All right, have a great night, and I'll see you in class.